let me
listen to this. But.
Let me give it just another maybe 2 minutes, if that's okay, guys, before we get started, just in case people are having trouble with the link. Oh, sure. Everybody see that?
Such demonic noise. Death is coming.
Okay, awesome.
So is this test over everything we've learned so far? Are you serious? But I'm so good at the translations. Dude, I'm so bad at Module 1. Like, you know the... Yeah, it's super easy. Like, once you... Because there's just one pattern, and then you just do it. Because you can just look at the equation and be like, oh, okay.
Yeah, I'm really good with trig, but not so much the algebra stuff.
Yeah. If I'm going to get any failing grade, it's going to be this test. Plug it in. Yeah. But you bet it's probably going to be like fill in the blank or something. Or at least on a few of them. And then I'm going to cry. Yeah. I forgot to do it. I forgot to do it during the actual like camera check. So I just do it right before I start. I'm like, here is my blank piece of paper. And then I was like, oh, fuck, I have to show my work. And so, oh, wait, I should probably not curse. Oh, no, I have to show my work. And so I finally did it, like, this last week. And I was like, whoops.
But I don't write down stuff for all of the problems. So, like, the quizzes, if there's 4 questions, I maybe end up having work for, like, 2 of them.
Yeah. 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 I'll draw like the unit circle, and then I'll do like the acronym we learned for like knowing which values are positive was like all students take calculus. And so I just put ASTC, and I was like, okay, we're good.
Yeah. And there's a trick for memorizing the unit circle. So like as long as you know quadrant 1, you can do the rest of it.
Definitely.
Yeah. That's the one thing I like about the unit circle is that it just repeats over and over and over again. Yeah, if it's negative, you go around clockwise instead of counterclockwise. Oh yeah, like I guess more than the value of the like. I think you're supposed to just like subtract 2 pi if it's like greater than the value.
Yeah.
It's so weird.
The way I always do it is I just like hold up my pencil and just like make it go in a circle and count how many times.
Yeah.
Oh, that's nice.
All right, so are we ready to get started? Okay, we'll go ahead and get started then. Are we recording? All right. Okay, so we'll just kind of go over this little plan here. If anybody has a question in the middle of it, feel free to speak up and ask it, and we can all try to collaborate and get the question answered. So we'll just start with the definition of a function. A function is a rule that assigns each element x in a set A exactly one element called f of x in a set B. Basically, all this is saying is that set A is the domain and set B is the range. It's just a fancy way of saying that. So f is always the rule to what you're going to do for your function. So if it's f of x equals x squared, that means square the number. Same thing, if f of x equals x squared plus 4, that means square then add 4. We're always going to use PEMDAS when we're dealing with functions. So with h of x equals x squared plus 4 over 5, you basically treat the numerator like it's in parentheses, so it's still PEMDAS. So you're going to square, then add 4, then divide by 5. Y equals f of x. Y or f of x is the dependent variable, and x is the independent variable. All this means is that y depends on x to change, and that x is x regardless. So that's pretty straightforward definition of a function. That's from 2.1 in the textbook. So evaluating a function, anywhere we see the x, it serves as a placeholder. So to evaluate a function f at a number, we substitute the number for the placeholder x. So we've seen the difference quotient before, kind of early on, before we started getting into average rate of change. But you'll notice that the difference quotient is actually the same exact thing that we're doing with average rate of change. F of a plus h minus f of a over h is the same thing as having your change in y over your change in x. F of a plus h minus f of a f of a plus h minus f of a over a plus h minus a. So the difference quotient that we were working with when we had to find f of a plus h, and then find the difference quotient, that's the same exact thing as finding the average rate of change. So I gave an example here, find f of a plus h, and f of a plus h minus f of a over h for f of x equals 3x squared plus 2. So we substitute the placeholder here for a. So f of a is going to be 3a squared plus 2. We just substitute this placeholder x, we put a in there. So that one's pretty easy. So then f of a plus h, same thing. We just take wherever the x is the placeholder, we're going to put a plus h in there. So it'll be 3 times a plus h squared plus 2. So then expanding that equation, we get 3 times a squared plus 2h plus h squared plus 2. Simplifies to 3a squared plus 6ah plus 3h squared plus 2. So then it's asking for the difference quotient. So we're going to take that whole thing, the f of a plus h minus f of a all over h, and we're going to simplify it. So the 3a squared will cancel out here in the top, and the 2 will cancel out here in the top, leaving you with 6ah plus 3h squared over h. And that simplifies to 6a plus 3h. So that is the difference quotient right there. Everybody's got that, I'm sure. All right, so the domain of a function. The domain is the set of all inputs for the function, or the set of all real numbers for which the expression is defined as a real number. So basically, these are the restrictions that are placed on x. The ones to remember are x cannot equal 0 in the denominator, x cannot be negative under an even radical, and x can be negative under an odd radical. For example, if you have the cube root of x equals negative 2, then you know that x equals negative 8. So x can be negative underneath an odd radical. A piecewise defined function is defined by different formulas on different parts of its domain. So this essentially means that a piecewise function can have different domains. And here's an example right here that shows you how they can have different domains. See, this one has a domain that x cannot equal 0 because it's 1 over x. This middle equation here has a domain where x cannot equal a negative number. And then x here on the bottom one, the cube root of x can equal all real numbers. So a piecewise function is defined by different formulas on different parts of its domain. All it's saying is that there can be different domains for a piecewise function. So for example, find the domain of f of x to the 4th over x squared plus x minus 6. So we know that x squared plus x minus 6 cannot equal 0 because we cannot divide by 0. So we set up an equation just like that. It's not equal to 0. And then we realize that we can factor this because x squared plus x minus 6 equals x plus 3 times x minus 2. So the same thing, you just replace it there. X plus 3 times x minus 2 cannot equal 0. So we know that x cannot equal 2 because 2 minus 2 is 0. And x cannot equal negative 3 because negative 3 plus 3 is 0. So that means that x is less than negative 3, or x is greater than negative 3 and less than negative 2, or x is greater than 2. In interval notation, the domain is negative infinity, negative 3, union, negative 3, 2, union, 2, infinity. And we use parentheses here because -3 and 2 are not included in the domain because remember it's less than here, not a less than or equal to. So we're going to use parentheses in interval notation. Another example, find the domain of g of x equals the square root of 7 minus 3x. So we know that 7 minus 3x cannot be a negative value because it's an even radical, right? It's a square root. So 7 minus 3x has to be greater than or equal to 0. 7 is greater than or equal to 3x. So we just added a 3x to both sides. 7 over 3 is greater than or equal to x, or x is less than or equal to 7 over 3. So sometimes you can rewrite these like these two inequalities are saying the same thing, but I like to rewrite it this way because it makes it a lot easier to write interval notation, however your brain works. So in interval notation, the domain is -infinity, comma 7 over 3. And we use a bracket because 7 over 3 is included in the domain. Because remember, it's less than or equal to 7 over 3. So we're going to use a bracket there. And we always use a parentheses for infinity because infinity is infinite. It's never included in the domain. We can't put a cap on infinity. All right, so another example. This one has two parts to it, two restrictions on the domain, because we have a radical in the numerator, which means that x cannot equal a negative value. And we also know that 2x squared plus x minus 1 cannot equal 0. So since x cannot be a negative value, we know that x has to be greater than or equal to 0. 2x squared plus x minus 1 cannot equal 0 because we cannot divide by 0. 2x squared plus x cannot equal 1. So we just added a 1 to both sides here. So we know that x cannot equal 1/2 because 2 times, let's see here, 2 times 1/2 squared plus 1/2 equals 1. So if we square 1/2, we get 1/4. 2 times 1/4 is 1/2. Plus 1/2 equals 1. And we know it cannot equal 1. So x cannot equal 1/2. So we know that x, putting those two restrictions together, we're putting this one, the x is greater than or equal to 0, and the x cannot equal 1/2. We're putting them together to say x is greater than or equal to 0, less than 1/2, or x is greater than 1/2. In interval notation, it's bracket 0, 1/2, union, 1/2, comma, parentheses. So again, bracket because 0 is included, because it's 0 is less than or equal to, and parentheses because 1/2 is not included, because here it's greater than or less than. All right, moving on to graphs of functions. This is in 2.2 of the textbook. To graph a function, plot the points x and y, or x and f of x. So the best way to do this is just make a table of values with x and f of x, plot the points in the table on the coordinate plane, and connect the points with a smooth curve. I'm pretty sure everybody's pretty comfortable with graphing lines and graphing. So just an example here, sketch a graph of f of x equals x squared plus 2. So we make a table of values here. I just started with some negative values and some positive values. So squaring -2, we get 4 plus 2 is 6. Same thing all the way through these values. And then we just plot the points on our graph. And here's the point 2, 0, 2. And this is what our graph looks like. Pretty straightforward. Graphing piecewise defined functions. So this graph consists of separate pieces of the function. Make a table of values, same thing for x and f of x for each part of the piecewise function. Plot the points in the table on the coordinate plane. If the points are not included on the graph, use an open circle for the point. If the points are included in the graph, use a solid circle for the point, and then connect the points. So the test might have something where it shows you a piecewise function. It might be a little bit backwards. It's going to show you a piecewise function and then ask you to find basically what the right table looks like, what the right piecewise function looks like. So you got to get kind of familiar with actually looking at the piecewise function and looking at these inequalities. So, but when we are given a piecewise function, for example, f of x equals -2 if x is less than -1. So anytime we have a value less than -1, we know that that f of x is going to equal -2. So f of x equals x if x is greater than or equal to -1 and less than or equal to 1. And f of x equals 3 if x is greater than 1. So the way I like to do it is to just separate out different parts of the function. So I'll write my x is less than 1, and I know that f of x is going to equal -2 for everything here. So I'll just write all the values for, and I'll include -1 here, even though it's not going to be included on the graph, because it's going to be all those points up to -1. So you want to still make sure that you write your -1 here, but it's not going to be included on the graph. I'll get to that in just a second. So same thing here, x is greater than or equal to -1 or less than or equal to 1. So we have our -1, our 0, and our 1. Those are all the values for this inequality. And we know that it's going to equal x. So f of x is just going to be the same thing as x. And then here for x is greater than 1, f of x is always going to be 3. So I just did all these values greater than 1, and we'll go ahead and talk about it now. The point -1, -2 from f of x equals -2. So this point right here, -1 and -2, is not included on the graph. And so are the points, the point 1, 3 from f of x equals 3. Since it's a greater than here, they're not included on the graph, but you still want to make sure that you mark them with an open circle because it's all the points up to x is 1. So you just want to make sure that you include that point, but you mark it with an open circle. So this is exactly what our graph is going to look like here. So we've got from x is greater than -1. We've got an open circle here. X is going to equal 3, or y is going to equal 3. So here we have f of x equals x, and that's for all the values from -1 up to 1, including those 2 points. And then right here we have f of x equals -2 if x is less than -1. We use an open circle there because it's not included. All right, the vertical line test. So an equation is a function if it defines y as a function of x. It must pass the vertical line test, and there can only be one output y for every input x. So you don't necessarily have to do the vertical line test and make a graph for every time you are asked if y is a function of x, but sometimes it does help just in case you're questioning your math or something like that. It might help to sketch a graph of it if you can, and then just see if it passes the vertical line test. It might be kind of time consuming, but it's definitely helpful on the homework. So the main thing is to just make sure that you only have one y for every input x. So we do this by isolating y and then seeing if we only have one y. So does 2x squared minus 4y squared equals 3 define y as a function of x? So we'll go ahead and the first thing we want to do is isolate y. So we have the equation right here. So it looks like, let's see, it looks like we subtracted a -2x squared from both sides. So that leaves us with -4y squared equals -2x squared plus 3. So then we're dividing by a -4. So y squared equals -2 divided by -4 is 1/2 x squared, and 3 divided by -4 is -3/4. So this is our new equation. Anytime you have a y squared, you're going to notice that you're not going to have a function anytime you have a y squared, because anytime you take the square root of y, you're going to get a positive and negative value for y. So same thing here. We had this y squared. We took the square root of it. So y can be positive square root of 1/2 x squared minus 3/4, or it can be negative square root of 1/2 x squared minus 3/4. So no, it is not a function because we have more than one output y for every input x. There's 2. So, and it also does not pass the vertical line test. So we'll go ahead and look at the graph. This is our same equation. This would be kind of hard to graph if you were just doing it on paper. But for example, this is what the graph looks like. We can see that it does not pass the vertical line test. So there's another way of telling that it is not a function. Sometimes you'll be given a graph and then you'll be asked if it defines y as a function of x. And you'll know that it is not a function if it does not pass the vertical line test. As long as you only have one point every time you have a vertical line going through, then it is a function. But if it passes through more than one point with that line, then it's not a function. So does the square root of y minus x equal 5 define y as a function of x? So we'll go ahead and check it out. The square root of y equals x plus 5. So we added an x to both sides, and then we square it. So we square the square root of y to get y, and then we square x plus 5. So we have y equals x squared plus 10x plus 25. So this shows us that we only have one output y, because it's only y can only equal this. So one output y for every input x. It doesn't matter if x is 2, it doesn't matter if x is -2. No matter what, we're always only going to get one y. So we'll look at the graph, and the graph does pass the vertical line test. Every time we have a vertical line, it only intersects through one point. Pretty straightforward. All right, moving on to the values of a function, the domain and the range. So the domain is a set of all x values for which f is defined. The range is all the corresponding y values or f of x values. So your domain, you're going to look at your graph here, y equals f of x, and then your domain is going to be all your x values. So you can just draw a line down, and then this interval right here is going to be your domain. Same thing on the range. Whatever the height of your graph is, however tall it is, from this point, this bottom point, up to this, the very top point that it reaches, that's going to be your range. So what I like to do is I like to just draw that line just like it does in this picture. Find the domain and range of f of x equals negative square root of 25 minus x squared from the graph. So sometimes you'll be given a graph and you'll be asked to find the domain and the range of that graph. So I'll just draw my line to find my domain on the x-axis, and then I'll draw my line to find my domain on the y-axis. Here we can see that it goes from -5 all the way to 5, and it goes from 0 all the way to -5 for the range. So here we have the interval. X is greater than or equal to -5 and less than or equal to 5. In the interval notation, we're using brackets because -5 and 5 are included in the domain. And then the range, the same thing, -5, excuse me, f of x is greater than or equal to -5 and is less than or equal to 0. In the interval notation, since they are included in the domain, bracket -5, comma 0, bracket. All right. Solving equations and inequalities graphically. So these, it says the solutions of the equation f of x and g of x are the values of x where the graph of f and g intersect. So if you're looking for a solution to a problem, like just the answers, like what does x equal, then this is the points where they intersect. And this part's a little bit kind of convoluted. The solutions of the inequality f of x is less than g of x are the values of x where the graph of g is higher than the graph of f. So basically, this is just asking you on which intervals is it increasing and decreasing. And we'll get to that in just a minute. There's an easier way to explain it. Right here, we'll talk about it. So the graphs of the functions f and g are given. So which is larger, f of 6 or g of 6? So the way that we want to do this is we want to look and find 6. So we'll go on our x-axis and find 6. Here's 1, 2, 3, 4, 5, 6. And then we want to see which function is larger at x equals 6. So at x equals 6, it looks like g is larger. So we would answer g is larger. G of 6 is larger than f of 6. So we do the same thing for f of 3 and g of 3. So we go to 1, 2, 3 on our x-axis, and then we see which one is larger. So here at x equals 3, f is larger than g of x, or excuse me, f of 3 is larger than g of 3. So then the next question says, find the values of x for which f of x equals g of x. So all the points where, all the solutions where the graphs are equal are where they intersect. So the values of x where they intersect is going to be where they're equal to each other. So it looks like f of 2 and g of 2, it looks like at x equals 2, they're equal because they intersect right here. And 1, 2, 3, 4, 5. At x equals 5, they're equal. 6, 7, and at x equals 7, they're equal. So it would be 2, 5, and 7. Those are the values when f of x equals g of x. Find the values of x for which f of x is less than or equal to g of x. So we want to find the intervals for when f of x is less than g of x. So it looks like right here, f of x is less than g of x. So it would be this interval right here from 1 to 2, and we would not include 2 here because at 2, f of x is equal to g of x. So we'll get down to that in just a second, the interval notation. But let's see, then it's also decreasing again right here. F of x is less than or equal to g of x right here. So it's less than or equal to from 5 all the way to 7. Find the values of x for which f of x is greater than g of x. So it would be the interval from 2 to 5 and from 7 to 8. So we'll go down here and check our answers. G of 6 is larger than f of 6. F of 3 is larger than g of 3. We found those intersection points 2, 5, and 7. And then here's the interval notation here. So one thing I wanted to show you guys, the interval at 1 is x is greater than or equal to 1 and less than or equal to 2. It's because those points are included here. Let's see, then we've got the interval at x is greater than 2 or 5, or x is less than 5, or x is less than 7, or x is less than or equal, x is greater than 7, or x is less than or equal to 8. Sorry guys, I'm getting a little bit mixed up with these less thans and great thans, so I'll try to stay on top of it. But we can see here that we put a bracket here on the edge of 8 because we have a greater than or equal to sign right here, because f of x is greater than or equal to, f of x is greater than g of x. So it's not at x equals 7, it's not greater than g of x because it's equal to g of x at x equals 7. So we're going to have an open bracket for 7 here, but it's greater than g of x at 8. So we're going to have a closed bracket there. Does that make sense to everybody? Okay. Moving on. Increasing and decreasing functions. So f is increasing on a, b, and c, d, and f is increasing on b, c. So it's just really anytime you have a positive slope, when it's going up like this, that's when it's increasing. And anytime it has a negative slope is when it's decreasing. And it's going to be between these intervals. Between a and b, it's increasing. And between b and c, it's decreasing. And between c and d, it's increasing again. So an example question, changing water levels. The graph shows the depth of the water in a reservoir over a 1-year period as a function of the number of days since the beginning of the year. So there's our graph. Determine the intervals on which the function is increasing and on which it is decreasing. So it looks like our graph is increasing from 0 all the way to about, what would you say that is? That's about 80, let's see, it's increasing. Oh, we're talking about the x values here. So on the interval from 0 to 150, this is 150 right here. So from 0 to 150, it's increasing. And it's also increasing again from 300 to infinity. So we see that it's increasing from 0 to 150 union 300 to infinity. And we don't have a negative infinity here because we're starting with 0 days. So we can't really go earlier than 0 days looking at this graph. So that's why there's no negative infinity there. All right, so at what value of x does w achieve a local maximum and a local minimum? So our local maximums are going to be basically the maxed out points of the graph, and our local minimums are going to be the minimized points of the graph here, just where it rises and where it dips. So our local maximum is going to be at x equals 150, because that's right where it maxes out here, x equals 150. The local minimum is going to be when x equals 100, or x equals 300. So we got it right there. I forgot to do the decreasing. So the decreasing from 150 to 300. And we're using open brackets because at these points from 150, it's neither increasing nor decreasing. It's just a point there. It's just equal to that. And then it starts to decrease. So then it's decreasing from 150 to 300. Then it just kind of bottoms out. So we use an open bracket because it's neither increasing nor decreasing here. And then it starts to increase again. So again, parentheses because the value is neither increasing nor decreasing. We've got our local maximum when x equals 150 and our local minimum when x equals 300. Find the net change in the depth from 100 days to 300 days. So we're going to take f of 300 minus f of 100. So net change equals change in y, which is y2 minus y1, or the w of 300 minus a W of 100. So at x equals 100, W equals 75. At x equals 100, W equals 75. At x equals 300, W equals 25. X equals 300, W equals 25. So the net change is going to be 25 minus 75, which is negative 50 feet. And we can see that looking at our graph. So from 100 to 300, we are going from 75 to 25. So it's decreasing by 50. So that also shows you that it's negative 50, because from 100 to 300, we're going down by 50. All right, just a little bit more about local maximum and local minimum. So this shows you where this one's got 2 local maximums and 2 local minimums. So you can have more than 1 local maximum and more than 1 local minimum. It's just all the points where it maxes out is going to be your maxes, and all the points where it minimizes are going to be your minimums. So the way that it's kind of said is local maximum is f of a at x equals a. So it happens at x equals a, but the local maximum value is actually f of a. So it's going to be your y value. That's going to be the actual local maximum. Same thing, your local minimum f of b, right here, this value happens at x equals b. Find all the local maximum and minimum values of the function and the value of x at which each occurs. Find the interval on which the function is increasing and on which the function is decreasing. So we've got a graph here. This is h of x equals negative x to the third plus 3x squared minus 4. So it's asking us to find the local maximums and the local minimums. So it looks like we have a local maximum right here, and we've got a local minimum right here. So our local maximum is going to be 0 at x equals 2. You see x equals 2 right here, and our local maximum is 0 for our y value. The local minimum is going to be negative 4, because that's f of 0. We've got x equals 0 here, at x equals 0. So f of 0 is negative 4. That's our local minimum right there. And it also asks us to find the intervals on which it's increasing and which is decreasing. So it's decreasing from negative infinity all the way to 0, and then it's increasing from 0 to 2, and then it's decreasing from 2 to infinity. So it's written this way: negative infinity to x to 0, and 2 to x to infinity. The way we write it in interval notation is negative infinity comma 0 union 2 comma infinity. They're always going to ask for interval notation. That's how they want it. All right, modeling with equations. So the first thing we want to do is identify the variable, translate from words to algebra, set up a mathematical model, and solve the equation and check your answers. These are the modeling with equations is kind of the preliminary stuff that we went over. It's some of the word problems that we had. So I just figured I'd go over it just to make it kind of easier to set up some of these questions, because I know some of them are kind of tough the way that they're worded. So a cell phone company charges a monthly fee of $10 for the first 1,000 text messages and 10 cents for each additional text message. Miriam's bill for text messages for the month of June is $38.50. How many text messages did she send that month? So the first thing we do is we identify the variable. What are we being asked to find? That's what it means by identify the variable. So we're being asked to find the number of text messages Miriam sent during the month of June. So we're going to let T equal the number of text messages. So then we translate from words to algebra. You want to take all these words and put it into numbers. So the fee, they said, was a monthly fee of $10 for the first 1,000 text messages. So that's going to be 10. So the number of text messages over 1,000 is going to be the total number of text messages minus 1,000. The cost for each text message over 1,000 is 10 cents. So we know that the cost for all text messages over 1,000 is going to be 10 cents times T minus 1,000. Because this is how many text messages over 1,000, and then for each one of those it costs 10 cents. So Miriam's bill, we're just going to let that equal B, which is also $38.50. Next thing we do is we set up a mathematical model. B equals 10, that's the monthly fee, plus 10 cents times T minus 1,000. So that's your model. Next thing you do is solve the equation. $38.50 equals 10 plus 0.10 times T minus 1,000. So then we subtract 10 from both sides. we get 2850 equals 10 cents times t minus 1,000. So then we divide by 0.10, which gives us 285 equals t minus 1,000. Add 1,000 to both sides, we get t equals 1,285. And then you check your answers, just basically check them for reasonableness. So that seems pretty reasonable that she would have sent 1,285 text messages. Seems like we got the right answer. All right, moving on. A plumber and his assistant work together to replace the pipes in an old house. The plumber charges $45 an hour for his own labor and $25 an hour for his assistant's labor. The plumber works twice as long as his assistant on the job, and the labor charge in the final bill is $4,025. How long did the plumber and his assistant work on this job? So the first thing we do is we identify the variable. We're being asked to find out how long the plumber and his assistant worked on the job, and we know that the plumber worked twice as long. So we're going to let A equal the time for the assistant and 2A equal time for the plumber. Translate from words to algebra. So the time for the assistant equals A, the time for the plumber equals 2A. The cost for the assistant, we know that he charges $25 an hour for his assistant, so it's going to be 25A. And the cost for the plumber is going to be $45 an hour. So we know that it's going to be 45 times 2A, which is also 90A. And the bill, we're going to let that equal B, which is 4,025. So we set up a mathematical model. B equals 90A plus 25A, because both of them working together is the total cost of the bill. So the bill is $4,025 equals 90A plus 25A. So 90A plus 25A is 115A. Dividing 4,025 by 115, you get A equals 35 hours. So that's how long it took the assistant to work. And then we know that 2A is how long it took the plumber to work. So he worked for 70 hours. Checking the answers for reasonableness, it seems pretty reasonable that they would work for that long, and the plumber worked twice as long as the assistant. So we know that we got the right answers. Okay, we got a mixture problem. A bottle contains 750 milliliters of fruit punch with a concentration of 50% pure fruit juice. Jill drinks 100 milliliters of the punch and then refills the bottle with an equal amount of cheaper brand of punch. If the concentration of juice in the bottle is now reduced to 48%, what was the concentration in the punch that Jill added? All right, so we identify the variable. We're being asked to find the concentration of the cheaper punch that Jill added to the mixture. So we're going to let X equal the concentration of the cheaper punch. So translate from words to algebra. So 750 milliliters of fruit punch at 50% is going to look like this, 0.50 times 750. So when Jill drinks 100 milliliters of the punch, we know that the 750 milliliters just lost 100 milliliters. So now we've got 0.50 times 650. So Jill replaces 100 milliliters that she drank. She replaces it with a cheaper punch, and we don't know the concentration of that cheaper punch. So we're going to take that 650 milliliters that we have. She added 100 milliliters, and we don't know what the concentration of that cheaper stuff is. So then the new concentration, they said, is 48% fruit juice. So the new concentration of the whole, we know that the whole amount of juice is 750 milliliters, and we know that it's going to be a 48% concentration. So we set up the mathematical model. The new concentration equals the 50% juice in the 650 milliliters plus the X% juice in the 100 milliliters. So we know that 48% of 750 is going to equal the 0.50 times the 650 plus the X times the 100. We solve the equation. We multiply these out. 0.48 times 750 is 360, and 0.50 times 650 is 325, and we just have 100x. So subtracting 325 from both sides, we get 35 equals 100x, and so we know that x equals 0.35. So the concentration of the cheaper brand was 35%. Check your answers. The 35% concentration for the cheaper brand seems reasonable to lower the total concentration of the juice from 50% to 48% if 100 milliliters was added. Sounds pretty right. It sounds like that's the amount of juice that it would take. Okay, last one. 2 fishing boats depart a harbor at the same time, one traveling east and the other south. The eastbound boat travels at a speed 7 miles per hour faster than the southbound boat. After 5 hours, the boats are 65 miles apart. Find the speed of the southbound boat. This was a homework question. I think the numbers are a little bit different, but we'll just go ahead and show how we work it out. So you want to draw a picture here, and they depart, since you know one is going eastbound and you know one is going southbound, you know you're going to have a right triangle here because they're headed in exactly a 90-degree angle. So we know that we can apply the Pythagorean theorem here. So the distance between them is 65, and we've got the speed. Let's see, we'll go ahead and go down here to our table. We're going to identify the variable. We're asked to find the speed of the southbound boat, so we'll let the speed of the southbound boat equal s. So we're going to translate from words to algebra. The speed of the southbound boat equals s. The speed of the eastbound boat equals s plus 7. So we know from the formula for distance that distance equals rate times time. So to know the distance, this is the distance that's traveled by the southbound boat. To know the distance, we've got to multiply it by the rate. So we know that the eastbound boat travels 7 miles per hour faster than the southbound boat, and they both traveled for 5 hours. Since they both traveled for 5 hours, you get speed traveled by time, so rate times time. So distance traveled by the southbound boat is going to be 5s, and the distance traveled by the eastbound boat is going to be 5 times s plus 7. Distance between the boats is 65, and we're going to use our Pythagorean theorem here. So you set up a mathematical model. The south distance squared plus the east distance squared equals the distance between squared. So 5s squared plus 5 times s plus 7 squared equals 65 squared. Solve the equation. You get 25s squared plus 5s plus 35 squared. That's just expanding this in here. 5 times s plus 7 equals 5s plus 35 equals 4,225. So then that gives us 25s squared plus 25s squared equals 350s plus 1,225 equals 4,225. So simplifying further, 50s squared plus 350s plus 1,225 equals 4,225. So we subtract 4,225 from both sides. We get 50s squared plus 350s minus 3,000 equals 0. So then we're going to divide by 50 here to give us s squared plus 7s minus 60 equals 0. Then we notice that we can factor that equation. So s squared plus 7s minus 60 also equals s plus 12 times s minus 5. So s equals negative 12 and s equals 5. So since the speed can't be negative, we're going to take the positive value for the speed, which is s equals 5. So that tells us that the speed of the southbound boat is 5 miles per hour. So checking your answers, 5 miles per hour for a boat sounds pretty reasonable. Sounds like we got the right answer. All right. Everybody good? Anybody have any questions so far? All right. So moving on to inequalities. So these are some of the rules for the inequalities. I kind of don't really pay attention to these very much. The only ones that I really try to pay attention to with inequalities are remembering to isolate x, and anytime you're multiplying or dividing by a negative number, it reverses the inequalities. So definitely this is in the textbook here. Definitely this can be helpful, but I don't really see it as that necessary. Just always remembering to reverse the inequality if you're ever multiplying or dividing by a negative number. So solving the inequality, 2 times 7x minus 3 is less than or equal to 12x plus 16. So we've got, just multiplying that out, we get 14x minus 6 is less than or equal to 12x plus 16. So we add 6 to both sides. We get 14x is less than or equal to 12x plus 22. And it looks like we've subtracted 12x from both sides. Gives us 2x is less than or equal to 22. X is less than or equal to 11. So in interval notation, negative infinity, comma 11 with a bracket because 11 is included in the domain because it's an equal sign right here. Okay, this one's a little bit tougher because we were dealing with fractions. Solve the inequality, negative 1/2 is less than or equal to 4 minus 3x over 5 is less than or equal to 1 over 4th. So the way to do this one is you want to find a common denominator for each value. Looking at 2, 5, and 4, we see that they have a common denominator of 20. They're all divisible into 20. So the easiest way to get a common denominator is to multiply by a fraction that is equal to 1. So here we multiplied by 10 over 10. We're going to take negative 1 over half, multiply it by 10 over 10. That's the same thing as multiplying it by 1, but we're getting that common denominator of 20. So that gives us this equation right here, negative 1 times 10 over 2 times 10, which is negative 10 over 20. And negative 10 over 20 is equal to negative 1 over half, because 10 is half of 20. All right, same thing with the 4 minus 3x over 5. To get that common denominator of 20, we're going to multiply by 4 over 4, which you take the top part and multiply it, and then the bottom part and multiply it. So you get 4 times 4 minus 3x over 5 times 4. So you get 16 minus 12x over 20. Same thing with 1 over 4. You're going to multiply it by 5 over 5. Same thing as multiplying it by 1, which gives you 5 over 20. And 5 over 20 is equal to 1/4, because we know that just by doing simple math. So this is our new inequality after we get our common denominator. Negative 10 over 20 is less than or equal to 16 minus 12x over 20 is less than or equal to 5 over 20. And you can get rid of those denominators because they're all going to be, this equals the same thing as this. Negative 10 is less than or equal to 16 minus 12x is less than or equal to 5. So it looks like we subtracted a 16 on both sides. So negative 10 minus 16 is negative 26. And then this leaves us with a negative 12x. And then 5 minus 16 is negative 11. All right, so then we're left, let's see, we're going to divide by a negative 12 here. So remember, when we're dividing by a negative number, it's going to reverse the direction of our inequality. So here we've got it reversed. So 26 over 12 is greater than or equal to x is greater than or equal to 11 over 12. So inequality is reversed. We can simplify 26 over 12 to equal 13 over 6 because they're both divisible by 2. So sometimes I like to switch around the inequality values as long as you're keeping your values on the right side of the inequality. I just moved the 26 over 12 or the 13 over 6. I moved it over here to this side and I flipped the inequality signs back. But you don't have to do that. It just makes it a lot easier, I think, to write interval notation. So you have 11 over 12 is less than or equal to x is less than or equal to 13 over 6. So in interval notation, we're going to use a bracket because we have equal then signs right here. So they're included in the domain. 11 over 12 comma 13 over 6. All right, these are nonlinear inequalities. Solve the inequality x squared plus 12x, or excuse me, x squared plus 2x is greater than 3. So you want to set it up as a 0 here. Let's see, we subtracted 3 on both sides. So we want to get one side equal to 0. So then we know that we can factor x squared plus 2x minus 3. That's x plus 3 times x minus 1 is greater than 0. So we know that x equals negative 3 and x equals 1 are critical values. So the best way to solve these nonlinear inequalities is to make a table or a number line. You can do it either way. I know in the notes and on the lectures, it shows us how to do it with a number line, but this was the easiest way that I could do it on a computer to show you guys. So you just want to set it up with your critical values here. Here I've got x equals negative 3. I've got x equals 1. Those are the critical values. And I've got all the intervals in between it. So x is less than negative 3. So then you have you want to take each part of the inequality, like the x plus 3 and the x minus 1, and set it up on one side of your table or your number line, and then multiply them together. What happens when they're multiplied together? So when x is less than negative 3, let's say it's negative 4. Negative 4 plus 3 is negative 1. So we're going to put a negative here. Negative 4 minus 1 is negative 5. So we're going to put a negative here. Negative times negative is a positive. All right, so when x equals negative 3, right here, negative 3 plus 3 equals 0. And when x equals negative 3 minus 1 is negative 4. That's going to give us a negative. 0 times anything is going to be 0. So you do that for all of your intervals here. And then it's asking us, when is the inequality greater than 0? So the plus sign denotes anytime it's greater than 0. And because there's no equal than sign right here, then it cannot be equal to 0. So the inequality is greater than 0 on the intervals x is less than negative 3, right here with the plus sign, and x is greater than 1. So in interval notation, negative infinity comma 3, union 1 comma infinity. All right, one more. Solve the inequality of 5x squared plus 3x is greater than or equal to 3x squared plus 2. So we have 2x squared plus 3x is greater than or equal to 2. It looks like we subtracted a 3x squared on both sides. So then 2x squared plus 3x minus 2 is greater than or equal to 0. That's subtracting a negative 2 from both sides. So then we notice that we can factor 2x squared plus 3x minus 2. That's 2x minus 1 times x plus 2 is greater than or equal to 0. So x equals 1/2 and x equals -2 are critical values because 2 times 1/2 equals 1, minus 1 is 0, and -2 plus 2 equals 0. Same thing, we're going to make a table or a number line showing our positive or negative values for each part of the inequality with the critical values. So I've got my x equals 1/2, and I've got all the intervals around it. I've got my x equals 0 just for good measure, and I've got my x equals -2. Here's my 2x minus 1, my x plus 2, and then when they're multiplied together. So when x is greater than 1/2, let's say x is 1. 2 times 1 is 2, minus 1 is 1, which is positive. And then let's say 2 plus 2 is 4. Or excuse me, I said it was 1. 1 plus 2 is 3, so that's a positive. Positive times positive is positive. So when x equals 1/2, we know that 2 times 1/2 equals 1, minus 1 is 0. 0 times anything is going to be 0. Same thing over here. You test all these values for all your different intervals on your number line or your table, and then you can multiply them together down here to tell you which intervals it's going to be positive or negative on. So we're looking for the values for which the inequality is greater than or equal to 0. So the plus denotes a greater than 0, and it can be equal to 0 this time. So that means this x equals 2 and this x equals 1/2 are going to be included in the domain this time. So x is less than or equal to -2 and x is greater than or equal to 1/2. In interval notation, -infinity, comma 2 with the bracket because it is included, union, bracket, 1/2, comma infinity. All right, these ones are a little interesting. Properties of absolute value inequalities. So it's a little bit tricky dealing with these. If you can remember when x has a less than sign right here, then you know that x is going to be greater than -c. And anytime that x, the absolute value of x is greater than c, you know that x is going to be less than -c. That's the way that I try to use to remember it. But really, any way that you can try to remember this to set up the proper equation, it's really when it's a greater than sign for absolute values, that's when things start to get tricky. That's when you have x is less than -c and x is greater than c. Anytime it's a greater than symbol is when it gets tricky. But when it's a less than sign, it's a lot easier to deal with because it just puts x right in the middle of it. It means that it's greater than -c and it's less than c. So let's try one. Solve the inequality. Absolute value of 5x minus 2 is less than 8. So because x is less than c, then x is greater than -c, or x is less than c. So right here, we put our -8. The 8 right here is going to be our c. So we take the inequality in the absolute value, put it right here in the middle, according to our properties for absolute values. So -8 is greater than, -8 is less than 5x minus 2 is less than 8. So it looks like we added a 2 to both sides. -6 is less than 5x is less than 10. And then we divide by 5. -6 over 5 is less than x is less than 2. In interval notation, since we don't have any greater or equal to signs, -6 over 5, comma 2. All right, solve the inequality. Absolute value of x plus 1 over 2 is greater than or equal to 4. So in this one, we have a greater than sign. This is where it starts to get kind of tricky. So x is going to be less than or equal to -c, and x is going to be greater than or equal to c. So it's going to be at two parts of the inequality here. X plus 1 over 2 is less than or equal to -4. And it looks like we multiplied by 2 on both sides to get rid of that denominator. So -4 times 2 is -8. And then we subtract the 1 from both sides. We get x is less than or equal to -9. So that's the first part of our inequality. So x plus 2 over 2, x plus 1 over 2 is greater than or equal to 4. It looks like we subtracted, let's see, we multiplied by 2 on both sides to give us x plus 1 is greater than or equal to 8. And then we subtracted 1, x is greater than or equal to 7. In interval notation, you put these two together, the x is less than or equal to -9, x is greater than or equal to 7. Putting them together, you get -infinity, comma -9 with a bracket, union, bracket 7, comma infinity. All right. Moving on to lines. The slope equals m, which also equals the rise over run, which also equals the change in y over the change in x, or delta y over delta x, which also equals y2 minus y1 over x2 minus x1. The slope of a vertical line is undefined. The slope of a horizontal line is 0. So we've got three different forms of an equation of a line, and we'll be asked to convert between these different forms pretty frequently. I saw on the quiz that they had the general form of the line, which kind of threw me for a loop. So we've got point slope form, which is y minus y1 equals the slope, or m, times x minus x1. We've got slope intercept form, y equals mx plus b. And the graph of every linear equation can be expressed in the general form, ax plus by plus c equals 0. So just be prepared to answer or convert. You might come up with a solution that's y equals mx plus b, but the answers might only be in this form, in this general form. So you'll have to convert your equation from y equals mx plus b to ax plus by plus c. And you can just do that with subtraction and addition. So always, always, always with lines, always find the slope first, anytime you're given points. So a negative slope, if the graph is decreasing, this is what it looks like if we have a negative slope. A positive slope, if the graph is increasing, this is what it looks like if we have a positive slope. A 0 slope if horizontal, there's a horizontal line that has a slope of 0, and no slope if vertical, it's undefined. Finding an equation of a line with a given point and slope. So we're given that the slope is 2 over 5 and the y-intercept is 4. So we know that since the y-intercept is 4, we know that one point on the line is 0, 4. So we've got everything we need to be able to use the point slope form. We've got our slope and we've got a point. So y minus y1 equals m times x minus x1. We'll go ahead and replace our y1 with the 4. So we've got y minus 4, and we know our slope is 2 over 5. So we've got 2 over 5 times x minus 0. Y minus 4 equals 2 over 5x. And then we've got adding 4 to both sides. We get y equals 2 over 5x plus 4. Or putting it into general form, we can subtract a negative 2 over 5x, subtract a 2 over 5x and subtract a 4 to get everything equal to 0, which would give us negative 2 over 5x plus y minus 4 equals 0. That's the same. Those two equations are equal to each other. That's the same thing. One is just in general form. So finding an equation of a line through two given points. Sometimes you're not given a slope. So always, always, always find the slope first. Find the slope of, or find the equation of a line through negative 2, 5, and negative 1, negative 3. So to find our slope, we're going to do y2 minus y1 over x2 minus x1. So we've got negative 3 minus 5 over negative 1 minus a negative 2. So we've got negative 8 over 1, which is negative 8. So now that we have our slope, we can, and we have a point, you just pick a point. So you use your slope, your negative 8, and then pick a point. It can be negative 1, negative 3, or it can be negative 2, 5, you just pick it. So I picked the first point, y minus 5 equals negative 8 times x minus a negative 2. That's the same thing as y minus 5 equals negative 8 times x plus 2. Y minus 5 equals negative 8 minus 16, just distributing there, and y equals negative 8, adding 5 to both sides, we get y equals negative 8x minus 11, or 8x plus y plus 11 equals 0. So we just added an 8x and added an 11 to both sides. Same thing. All right, parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines, slopes are negative reciprocals of each other. The y-intercept equals 6, parallel to the line 2x plus 3y plus 4 equals 0. So we know that a point on the line is 0, 6. So we take our equation, and it looks like we subtracted a 2x and subtracted a 4. We're going to try to get it into y equals mx plus b form so that we can determine what the slope is. So then dividing by 3, we get y equals negative 2 over 3x minus 4 over 3. So now we know that our slope is negative 2 over 3. So now that we have a point, we have that y-intercept point, we can use point slope form again. Y minus y1 equals m times x minus x1. So taking that point, y minus 6 equals negative 2 over 3x minus 0. Y minus 6 equals negative 2 over 3x. And adding 6 to both sides, we get y equals negative 2 over 3x plus 6. So when we check our answer, let's see, our original equation had a slope of negative 2 over 3. And this does have a y-intercept of 6 because that b and ymx plus b is going to be your y-intercept. So we got it right. All right, so find the equation of a line through -2, -11 and perpendicular to the line passing through 1, 1 and 5, -1. All right, so always find your slope first, and remember that the slope will be the negative reciprocal of the slope of the line given. So the first thing we want to do is find the slope of the line given. So we're going to use the change in y over the change in x equals -1 minus 1 over 5 minus 1, which is -2 over 4, which is -1/2. So we know that the slope of our new line, the one that goes through -2, 11, is going to be the negative reciprocal, which is going to be 2 over 1, which equals 2. So now that we have the point -2, 11, and we have the slope 2, we can use point slope form. Y minus a -11 equals 2 times x minus a -2. So then that's the same thing as saying y plus 11 equals 2 times x plus 2. And then we distribute here, y plus 11 equals 2x plus 4. And then subtracting 11 from both sides, we get y equals 2x minus 7. That's the equation of your line that passes through -2, -11, and it is perpendicular to the line that passes through 1, 1, and 5, -1, because it's a negative reciprocal. -1 over 2 is a negative reciprocal of 2. All right, moving on to modeling variation. Direct variation, y equals kx. Y varies directly as x, or y is directly proportional to x. K is called the constant of proportionality. Express a statement as an equation. Use the given information to find the constant of proportionality. P is directly proportional to T. If T equals 300, then P equals 20. So we know that since it's directly proportional, we're going to use that y equals kx formula there. So P is directly proportional to T. So then we just replace our values here. 20 equals k times 300, and k equals 20 over 300. So then you just reset up your equation with the k value that you found, and you've got p equals 20 over 300 t. So then you can start finding values for other p's and t's once you have that k. Inverse variation, y equals k over x. Y varies inversely as x, or y is inversely proportional to x. Express the statement as an equation. Use the given information to find the constant of proportionality. W is inversely proportional to the square of r. If r equals 6, then w equals 10. So we've got w, we're going to use that k over x, y equals k over x equation. So it is inversely proportional to the square of r. So we've got k over r squared. So when w equals 10, r equals 6. So we've got 10 equals k over 36, and then multiplying by 36, we've got k equals 360. Resetting up our equation, we get w equals 360 over r squared. We're just taking that k value and replacing it with what we found here in our original equation. Combining different variations, z equals kxy. Z is proportional to the product of x and y, or z varies jointly as x and y, and z is jointly proportional to x and y. Z equals k over x, or excuse me, z equals k times x over y, or it can be written as kx over y. Z is directly proportional to x and inversely proportional to y, or z varies directly as x and inversely as y. Express a statement as an equation. Same thing. It's just saying h is jointly proportional to the squares of p and w. So it's jointly proportional to them. So there's just going to be the product. If p equals 2 and w equals 1/3, then h equals 36. So we've got h equals k times p squared times w squared. So 36, and just replacing our p and our w with the values given, we've got k times 2 squared times 1/3 squared. So 1/3 squared is 1 over 9, 2 squared is 4. And it looks like let's see, 4 over 9. 4 times 1 over 9 is 4 over 9. So we've got k times 4 over 9, and 36 divided by 4 over 9 is 81. So we've got k equals 81. So resetting up our equation, h equals 81 p squared w squared. And one more, t is proportional to the product of x and y and inversely proportional to r. If x equals 2, y equals 3, and r equals 12, then t equals 25. So setting up our equation, we've got t equals kxy over r, because it's directly proportional to x and y and inversely proportional to r. So if you just remember to put it in the denominator when it's inversely proportional and put it in the numerator when it's directly proportional, that's really all it's asking. And your k can either be over to the side or it can be on top with your x and y. So you've got just replacing our values, 25 equals k times 2 over 3, or times 2 times 3 over 12. So k equals 6 over 12, or k, sorry, 25 equals k times 6 over 12. 25 equals k times 1/2. So then dividing 25 by 1/2, you get k equals 50. Setting up our equation, t equals 50 times xy over r. And last but not least, the unit circle. This is everybody's favorite part. So there's our unit circle. We've got 0 and 2 pi over here. The terminal point of 0 and 2 pi is 1 comma 0. We've got pi over 2 on top. We've got the terminal point is 0 comma 1. And we've got pi over here to the left. We've got the terminal point is negative 1 comma 0. And 3 pi over 2. The terminal point is 0 comma negative 1. So the unit circle is a circle of radius 1 centered at the origin on the xy plane. X squared plus y squared equals 1. That's the equation for the unit circle. And that's the same thing as saying cos squared t plus sine squared t equals 1. X squared and y squared, that's the same thing as cos squared and sine squared. That's all it's saying. So definitely want to make sure you commit this to memory. These equations right here on the top. Now, we don't really need cotangent. This one here, the 1 over tangent, you can use this for cotangent, the cosine over sine, but those two, either way you want to do it will work. So, but I don't really even pay attention to this one right here, 1 over tangent, because I know when I already have my sine and cos values, then I can find what tangent and cotangent are. You just have to remember in which order they are. Tangent is always going to be y over x. So definitely want to remember sine squared t plus cos squared t equals 1, because that's your Pythagorean identity. And these two are very helpful when you're given one of these values, but they're not really necessary, but they can be very helpful for some questions. So I don't know if they'd be necessary for this exam, but definitely if you can work on committing these two to memory for cosecant and secant squared, then it's helpful. And one more thing to commit to memory for the unit circle, common terminal points. These are the only ones that you have to remember. If you can remember these, you can figure out any terminal point around the unit circle. So you want to remember that 0 is 1 comma 0. So it's got a cosine of 1 and a sine of 0. You want to remember that pi over 6 or 30 degrees is a square root of 3 over 2 comma 1/2. Pi over 4 is always going to be square root of 2 over 2 for both sine and cos. And pi over 3 is going to be 1 over 2 comma square root of 3 over 2. And pi over 2 is going to be 0 comma 1. I always just try to remember that the sine of pi over 6 is 1/2. You can see that. So then you know that your only other one that you have to remember, you know that these two are the same. Pi over 4 is going to be the same regardless. So anytime you have an angle that deals with any kind of thing that's divisible by pi over 4, you know that you're going to have these two values for your sine and your cos. But these two are the ones that are kind of tricky to remember. So if you can just remember that the sine of pi over 6 is 1/2, then you know that pi over 3 is going to be reversed. It's just the reverse of pi over 6. So definitely commit that to memory. All right, think of the reference angle as a helpful tool so you don't have to remember every single negative value. These are your reference angles right here. These are always going to be your reference angles. If you can remember these values here, then you'll always be able to find it no matter what quadrant it's in. So the signs plus or minus are determined by the quadrant in which the angle lies. The reference angle, or bar t, is the angle distance from t, the given angle, in the x-axis. So it's really just how far away from the x-axis is your angle. That's going to be your reference angle. So you always want to draw the unit circle, draw your given angle on the unit circle after you get it drawn, determine which quadrant the given angle lies in, find the reference angle, find the terminal point QA comma B of the reference angle. So don't really have to pay attention to the QA comma B, just find the terminal point, the X and the Y, or the sine and the cos and the sine, and then determine the terminal point of the given angle, which is going to be plus or minus cosine or plus or minus sine. So the given angle terminal point will have the same values as the reference angle, but the signs plus or minus will change depending on the quadrant. So just always try to figure out what your reference angle is. And then once you know the quadrant, then you can draw the coordinate plane. And remember when sine is positive and cosine is positive or negative, and then you can determine whether they're going to be negative in that quadrant. This is also helpful. The All Students Take Calculus, ASTC, helps to determine when trigonometric functions are positive. So if you're ever questioning your answers, if you get asked one of those questions where it's like, find the 6 trigonometric values for a given angle, then you can check it and make sure that you got them all right, positive and negative, because in quadrant 1, they're all positive. In quadrant 2, only sine is positive because cosine is negative. We're going negative in the x direction here. Tangent is positive in the 3rd quadrant because you've got a negative sine, you've got a negative cosine, and a negative divided by a negative because tangent is sine over cosine. Then you know you're going to have a positive value for tangent here. And then cosine is positive here because we're going positive in the x direction. All right, even odd properties. Now we might get asked a question I'm not really sure about on the exam, but you might on a quiz or something, we could get asked whether a function is even or odd. But this is really just a helpful tool to quickly determine if the values are positive or negative. You can basically see if f of negative x equals f of x. This is for sine, cosine, tangent, and cotangent. And odd, f of negative x equals negative f of x is for cosine and secant. So it's really just a helpful tool. I don't really use it a whole lot, but it's a lot faster sometimes. All right, so when you're asked to write a trigonometric function in terms of another trig function, so it says write tan t in terms of sine t, where t is in quadrant 1. So you want to write tan in terms of nothing but sine. That's what it's asking. Just you want to define tangent by terms of sine. So we know that tangent equals sine over cosine. So we want to get rid of that cosine because we only want to define it in terms of sine. So we know that cosine squared t plus sine squared t equals 1. So we know that cosine squared t equals 1 minus sine squared t. And we know that cosine of t, taking the square root of both sides, cosine of t equals plus or minus the square root of 1 minus sine t. And we know that since t is in quadrant 1, that was given to us, we know that cos is positive. Because remember, in quadrant 1, cosine is positive. So we know that the cos of t is the square root of 1 minus sine squared t. And so replacing that cos value that we have up here, replacing that with the sine term that we came up with, you get tangent of t equals sine t over square root of 1 minus sine squared t. That's how you write it in terms of another one. All right, so this is something that I think somebody was talking about before we got started. Large angles can be simplified by converting to 2 pi and subtracting. It makes it a lot easier to draw it on the unit circle than it does. It's fine to go ahead and count up the slices. I like to do that too, just to check it sometimes to make sure my math is right. But any angle plus or minus 2 pi will always have the same terminal point because all you're doing is going around the unit circle 1 full revolution. So for example, 26 pi over 4. So we know that 2 pi equals 8 pi over 4. So we want to see how many times does 2 pi go into 26 pi over 4. So we see that 3 times 2 pi is 6 pi, and 3 times 8 pi over 4 is 24 pi over 4. So we're just taking that 2 pi value, we're converting 2 pi into terms of pi over 4, and then we are seeing how many times that 2 pi will go into our given angle, and then we're subtracting it. So 26 pi over 4 minus 24 pi over 4 equals 2 pi over 4, which is the same thing as pi over 2. And 26 pi over 4 and pi over 2 have the same terminal point. So it's a lot faster than counting if you can remember to do it this way. And I'll show you kind of down here how it works when we get to the unit circle. Another way to do it is you can just start with one slice of the angle and count up to how many slices are in the given angle. So for example, 26 pi over 4 can start with one slice of pi over 4 and count to 26. So here's our one slice of the pie right here. This is pi over 4. So we can just go around the unit circle and count 26 times if we want to. You can draw it like this and just go 1, 2, 3, 4, 5, 6, 7, 8. See, we've got 3 pi over 4, 4 pi over 4, 5 pi over 4, and you can keep going. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. But you see, it's the same thing as pi over 2. So we could just say that we go around the unit circle 3 times, because remember up here, we were able to put 2 pi into 26 pi over 4. We were able to put it in there 3 times. So you can just go 1, 2, 3, and then that 26 pi over 4 minus 24 pi over 4 equals 2 pi over 4. So then you just go 1, 2 pi over 4 more, which gives you pi over 2. So it does work either way that you want to do it. All right, these ones are kind of tricky sometimes. The pi minus t. So I made some lines here. This is what I like to do. I like to draw lines to kind of denote where it is. You can do the math on it too. So you know that pi is also equal to 4 pi over 4 because 4 divided by 4 is 1. So you can put it into terms of pi over 4. So you can just do pi minus pi over 4 is 4 pi over 4 minus pi over 4, which equals 3 pi over 4. You can do it that way, or you can just take your line here, say we start with pi over 4, draw a line straight across the circle right here, and then right here is going to be pi. You can see this is pi, one way around is pi, and then minus your pi over 4, you're subtracting this pi over 4 right here, you get 3 pi over 4. So there's a few ways to do it. Negative t, so negative pi over 4 equals 0 minus pi over 4, or it can be 8 pi over 4 minus pi over 4. It has the same terminal point as 7 pi over 4. So we can just go from here, from 0, we just go negative pi over 4. You're going in a clockwise direction, just going down from 0 to negative. It's got the same terminal point as 7 pi over 4. So another way to do negative t is to just draw a line straight down from your angle. That's negative t. All right, so then we've got pi plus t. So you can do pi plus pi over 4, which is 4 pi over 4 plus pi over 4 equals 5 pi over 4. Or you can just look at pi and add another pi over 4 to it. So then you've got 5 pi over 4. Or you can take this line and find this was, you just draw this way, and then you draw another line down, and then this is going to be your pi plus 4. You can do it with lines, you can do it with math, or you can just kind of eyeball it. I like to draw my slices here, and then I just see what pi is. Pi is over here, and I just add one more slice to it. So it gives me 5 pi over 4. All right, and then 2 pi plus t is 2 pi plus pi over 4, which is 8 pi over 4 plus pi over 4, which equals 9 pi over 4, or pi over 4. It has the same terminal point. So we go 2 pi all the way around, plus pi over 4 is just pi over 4, or 9 pi over 4. They have the same terminal point. So you're going 8 pi over 4, 1, 2, 3, 4, 5, 6, 7, 8, plus another one is 9 pi over 4. And then 2 pi minus t. So this is the same thing as negative t. 8 pi over 4 minus pi over 4 is 7 pi over 4. So you're just taking that 2 pi or the 0 minus pi over 4. All right, find the 6 trigonometric functions with a given angle t. When dividing fractions, you're going to deal with dividing fractions a lot. There's a quite a different few ways to do it, but my favorite way to do it, just so I don't mess anything up, is I always set up the fractions a over b over c over d. And then you know that a times d, that is the same thing as saying a times d over b times c. So if you have a radical in the denominator, you need to rationalize the denominator to simplify. And the easiest way to do that is to multiply that radical over itself, multiply by that radical over itself, which is the same thing as multiplying it by 1. So the expression is still equal, but it gets rid of the radical in the denominator. For example, this is one that we'll see a lot dealing with pi over 6 and pi over 3. So 1 half over square root of 3 over 2, a times d over b times c. So we've got 1 times 2 over 2 times the square root of 3. So that's the same thing as 2 over 2 square root of 3. And we divide by 2 here. We just cancel out the 2's. We get 1 over square root of 3. We got a radical in the denominator. We don't want that. So we want to simplify it. So we take that same radical that we have in the denominator, that square root of 3, and we're going to multiply it by that radical over itself. So we get 1 over square root of 3 times square root of 3 over square root of 3 equals 1 square root of 3 times the square root of 3 times the square root of 3. So 1 times the square root of 3 is just a square root of 3, and the square root of 3 times the square root of 3 is 3. This is simplified, so this is our answer right here. Same thing as multiplying by 1, just to get rid of the radical in the denominator. All right, so find a terminal point determined by a given angle t. So we're given 3 pi over 4. Determine the quadrant. So we're going to draw the unit circle, and then we're going to mark our 3 pi over 4 because we counted 1 pi over 4, 2 pi over 4, 3 pi over 4. Mark our 3 pi over 4. We see it's in quadrant 2. All right, determine the reference angle, pi over 4. So that's our distance. We've got 3 pi over 4. The distance to the x-axis is just another slice of pi over 4 here. So that's our reference angle, is pi over 4. So automatically, since we have that memorized, we know that the sine and cos values are going to be square root of 2 over 2 for both. But we gotta determine whether they're going to be positive or negative depending on the quadrant. So we've determined the terminal point of the reference angle, square root of 2 over 2, comma square root of 2 over 2. And then we determine the plus or minus for sine and cos depending on the quadrant. So in quadrant 2, we know that cos is negative. And sine is positive. So then you just apply those values. You take this right here and you just apply it there. So we know our cos is negative and our sine is positive. So terminal point of 3 pi over 4 is negative square root of 2 over 2, comma square root of 2 over 2. All right, show that the point negative square root of 5 over 3, comma 2 over 3 is on the unit circle. So we know that the point will be in quadrant 2 because cos is negative and sine is positive. So we're going to use our Pythagorean identity here because we've got the 2 points and we've got to prove that it's on the unit circle. So cosine squared plus sine squared has to equal 1. So we take negative square root of 5 over 3 squared plus 2/3 squared equals 1. Negative square root of 5 over 3 equals 5 because square root of 5 squared is 5. Or negative square root of 5 squared 5 is 5. And then 3 squared is 9. So then we take 2/3 squared, which is 4/9, and 5/9 plus 4/9 equals 9/9, which is equal to 1. So we've proven that negative square root of 5 over 3, comma 2 over 3 is on the unit circle in quadrant 2. Sometimes you'll be asked to find the reference angle when you're dealing with radians. So we're asked to find the reference angle for t equals 3.4 radians. So we know that 3.4 is slightly larger than pi, or 3.14. And we know that 3.4 is in quadrant 3. So I always like to draw my unit circle, and just for visualization, I like to mark where it's at. So I know that my reference angle is going to be this little slice right here is going to be the distance to the x-axis. So I know that I'm going to take 3.4 minus pi, which that's the exact value. A lot of times on WebAssign, it's going to ask you to input it like that. And I've seen some places on the homework or in the notes, it'll ask for an estimate, like an estimate is okay. So it might be both ways, but always I would say try to shoot for this exact answer here. So 3.4 minus pi. So you can see if you take this little slice plus this pi, that's 3.4. And if we subtract pi from it, then that gives us this little slice right here. So that's how you know you're doing it right, is if you draw the unit circle. It's a little different when you're dealing with something that's larger though. So find the reference angle for t equals 5.60 radians. So we know that 5.60 is slightly less than 2 pi, or 6.28. So 5.60 is in quadrant 4. So we draw our unit circle, draw where 5.60 is probably at. I don't know if that's exactly where it's at, but it's probably pretty close. The reference angle is 2 pi minus 5.60, which is exact. Or we can estimate it if it ever asks you for an estimate, if that's okay. But most of the time, it's going to ask you for this exact answer. And you can test it by taking 2 pi as the whole circle, and then you're just subtracting your angle, which is 5.60. So this whole circle minus your angle gives you this little red slice right here. And that's your reference angle. That's the distance to the x-axis. All right, and I think this is the last thing right here, guys. Sorry if it's been taking quite a while. I'll try to keep it low on time. But find the 6 trigonometric functions given. Cosecant of t equals 3, and t is in quadrant 2. So we know that sine will be positive and cosine will be negative because it's in quadrant 2, which means that tan, I like to go ahead and predetermine if all my values are going to be positive or negative, and I can always base it off of sine and cosine. So I know that if one of the values between sine and cosine is positive and negative, if there's only one negative value between them, then I automatically know that tan and cotangent will be negative, because you get a positive over a negative, which is a negative, and you get a negative over a positive, because tangent and cotangent are sine over cos and cos over sine. So cosecant is positive because that's given, or you can just say that 1 over sine of t, which is, in this case, sine is positive because it's in quadrant 2. So we get 1 over a positive, which is positive. So we know that cosecant is going to be positive. All right, secant will be negative because our cosine is negative because it's in quadrant 2. So we've got 1 over cosine, which is 1 over a negative, which will be negative. That's just something that I like to do to go ahead and predetermine so I can check my answers and make sure I got all my positives and negatives right. There's a lot of different ways to do this. I've seen people doing it with the right triangle way, the opposite hypotenuse. This is just the way that I like to do it. It makes sense in my brain. So whatever works for you, that's what works for you. So I'm all for it. I think anything that you can make it work is great. So cosecant of t equals 1 over sine t. I believe this is the only one that I pulled from the homework. This was not a new one that was pulled from WebAssign, but we'll just go ahead and explain how it was done. So since we know that the cosecant was given, cosecant is 3, so 3 equals 1 over sine t. So we multiply both sides by sine t. So you get 3 times the sine of t equals 1. And then you divide both sides by 3. So you get 1 divided by 3. So sine of t equals 1/3. And we know that sine is positive because it's in quadrant 2. All right, so then we're going to try to find cosine. So anytime you have a sine or a cosine, you got to use that Pythagorean identity. Cos squared t plus sine squared t equals 1. So then we get cos squared t equals 1 minus sine squared t. So then we're going to take cos squared t equals 1 minus 1/3 squared t. So we're just replacing that sign with our 1/3 that we just found. So then we're going to square it. Cos squared t equals 1 minus 1 over 9. So then cos squared t equals 9 over 9 minus 1 over 9, which is 8 over 9. Got to take the square root of both sides. So cos of t equals plus or minus square root of 8 over square root of 9. And it's going to be negative because it's in quadrant 2. We already know cosine is going to be negative. So we've got negative square root of 8 over 3. But we're not done with that one because the negative square root, or the square root of 8 can be simplified further. So negative square root of 8 over 3 can be simplified. So negative square root of 8 over 3 is the same thing as a negative square root of 4 times 2 over 3. So we know that we can take anything in here that is a square, we can move it outside of the radical. So we take that square root of 4 and we put it outside of the radical. The square root of 4 is 2. So we get negative 2 square root of 2 over 3. That's a simplified answer. That's the same thing as this, but it's simplified. All right, so now that we've got sine and cosine, we can figure out what tangent is. So we just take our two values that we have. We've got 1 over 3, and it's a negative, over 2 square root of 2 over 3. So we take a times d over b times c. So we've got 1 times 3 over 3 times 2 square root of 2. And that's the same thing right here. So then we can cancel out our 3's or divide by 3. And we've got negative 1 over 2 square root of 2. All right, we got a radical in the denominator, so we need to get rid of that. So I take that same radical and I just multiply it over here. So we've got negative 1 over 2 square root of 2, and you multiply that by the square root of 2 over square root of 2. So you get 1 square root of negative 1 square root of 2 over 2 square roots of 2 times the square root of 2. The square root of 2 times the square root of 2 is 2, times 2 is 4. So you get negative square root of 2 over 4. That's simplified. Cotangent is going to be the exact opposite, cosine over sine. So you just reverse the same equation that you just did, except it's reversed. So negative 2 square root of 2 over 3 over 1 over 3. You take a times d over b times c. So you get 3 times 2 square root of 2 over 3 times 1. The 3's cancel out. So you get negative 2 square root of 2 over 1. And that's the same thing as negative 2 square root of 2 over negative 2 square root of 2, because anything over 1 is going to be itself. All right, so then the secant is the last one we have to find. That's 1 over the cosine. So we know secant's going to be negative because cosine is negative. So we get negative 1 over 2 square root of 2 over 3. So I like to just go ahead and make it another fraction. 1 over 1 is the same thing as 1, just so I can do my a times d and my b times c. So I'm going to take 1 times 3 over 1 times 2 square root of 2. That gives me negative 3 over 2 square root of 2. And we got to do the same thing because we got a radical in the denominator. So we take negative 3 times the 2 square root of 2 times square root of 2 over square root of 2 gives us negative 3 times the square root of 2 over 2 square root of 2 times the square root of 2. So 3 square root of 2. And then we've got square root of 2 times square root of 2 is 2 times 2 is 4. So that is our secant right there. And the last thing I just wanted to kind of touch on, this is not going to be on module 1 exam, but the net change and the average rate of change of a function, just wanted to kind of talk about it. Average rate of change is the same thing as the difference quotient. So we're kind of familiar with this. It's the change in y over the change in x, f of b minus f of a over b minus a. The secant line is the slope. That's the average rate of change. That's the same thing as what's called the secant line. So your net change is going to be your change in y. It's going to be y equals y2 minus y1. Average rate of change equals change in y over change in x. Once you find your net change, you don't have to really do it again. You can just take your net change over your change in x equals y2 minus y1 over x2 minus x1. So a function is given. Determine the net change and the average rate of change. F of z equals 1 minus 3z squared. Z equals negative 2 and z equals 0. Net change is change in y. So we take our f of 0 minus our f of negative 2. And you always want to take the value that's greater first. That's going to be your x2 or your y2. You want to take the value that's greater. So it's going to be 1 minus 3 times 0 squared minus 1 times 3 times negative 2 squared, which is 1 minus 3 times 0, or minus 1 minus 3 times 4. So you get 1 minus 0 minus 1 minus 12. 1 minus negative 11 is 12. Average rate of change equals the net change over the change in x. Net change over x2 minus x1. And like I said, x2 will always be the value that is greater because 0 is greater than negative 2. So 12, we can just take our net change since we already found net change. It's just faster. Take your net change and put it on top, and then take your x values. So you've got 0 minus negative 2. You get 12 over 2, which is 6. And you can see the graph here. This is the graph of 1 minus 3z squared. And we've got a net change here in our y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's right. And then we've got, it goes over 2 and up 12, which means 6. That's going to be our slope there. Slope is the same thing as average rate of change. And that's it, guys. That's all I got. That's pretty much everything. So if you guys have any questions or anything that I went over, questions about anything, unit circle, or if you guys just want to talk about stuff, I'm all for it. What did you guys think?
That was pretty good. I have a question.
Yeah, for real.
I have a question not about the review, but where do we actually access the test?
It should be under grades. That's the only place that I saw it is when you click on grades and then you scroll down to where exam 1 is, then that's like really the only place that I found it. It's not posted anywhere and there's no due date or anything, but we got to get it done by tomorrow night. But yeah, if you click on grades and you scroll down to exam 1, there should be an option to begin quiz.
That's so crazy.
Becca, I have a question.
Yeah.
On that, well, the part that you're on right now, when you were talking about doing like the pi minus t and using the graph to like map out the square for the slices, does that only work for pi minus 4? Like if it was, it's like, say if the value of t was like pi thirds, will we have to do cut it into 6s or cut it into?
You know, that's a good point. I'm not really sure if the lines would still work, but I know that the math would still work on it, like this. But I saw somewhere on, it was either WebAssign or the book, and I was trying to find it when I was trying to put this together. But if you draw lines like just straight across where it is. Like it pretty much, let's see if we had pi over 3 here. We had pi
It
over
was
3.
making sense when you explained it, but then I started wondering, if it was like because that cuts it into kind of fourths, but I didn't know if it would be the same concept, like if it was pi thirds or pi sixths, and you had to cut it into.
It should still work if you draw the lines. Like for the most part, logically, it's in my mind. Let me go ahead and draw it on a piece of paper real quick. Let's see, pi over 3. If you can keep it straight, then I don't see why it wouldn't work.
Okay.
You should still be able to use the same concept there, but it might be a little bit more difficult. But definitely the math on it will help if you can convert pi into the terms of, like, so let's say pi in terms of pi over 3 is going to be 3 pi over 3. So you can just take pi over 3 plus 3 pi over 3, which gives you 4 pi over 3.
Right.
So that will always work. Maybe it was a bad example with the lines, but it definitely works for pi over 4.
No, that was a good example. I was just wondering if it was, if it worked for the other ones, because it didn't. No, that did help it make sense, because when I saw it on the homework assignment, it wasn't making sense, like how they didn't really explain it. So your explanation made sense. I was just wondering if it was the same for different values, or like besides a pi fourth.
Okay, awesome. Yeah, anytime converting it, as long as you convert that 2 pi or the pi into the terms of the angle that you're trying to add or subtract, it should always work. And then you can just draw your unit circle and count how many slices you work. Definitely the counting of slices always works. But what do you guys think of the study session? Was it pretty good for the first time? Not bad. I'm trying not to talk too much and take up too much of your guys' time, but I definitely want to open it up for anything that anybody's confused on, or if we need to go over something again.
Oh, fam, that was great.
All right, good. Awesome.
Wow.
All right. And there's a Google Drive link for this, so you guys can have it and you can look at it on your phone. You just have to make sure that you download the file to be able to see all the equations, because I use this equation input in Word or whatever. But yeah, hopefully you guys feel a little bit more ready for the exam, and I wish you all luck on the exam. Hope you do well on it.
Thanks, Becca, a lot.
Thanks.
No problem, guys. Anybody have any questions?
No, I'm good.
Cool. Well, thank you guys so much for showing up to the first Zoom study session. Maybe we can do this again.
Oh, for sure. For sure.
Yeah, I know I'm gonna need it. So.
Yelling in his room? Yeah, the Cowboys came back from. Yeah, no, 40-39, right? Yeah. They screaming.
All right, guys. Well, good luck on the exam, and